Circle Basics, Tangents, and Central Angles by Think Sapling. So what is a circle? All a circle's points are equidistant from the center of the circle. So let's say you have the circle and you have the center of the circle. If you take any point from the outer edge of the circle and you compare the distance to the center of the circle, it will be the same distance. For example, we have the circle here. We take this point out from the outer edge, we compare it to the center of the circle. This is 2 inches. If you compare this point to this is also 2 inches, and so on. So this point is 2 inches, this point 2 inches, this point 2 inches. Any point in the circle, even unshown points, they will all be 2 inches. Okay? These are the basic parts of a circle whenever you see a diagram. So this is the main part, it's the center of the circle. This is the radius. It goes from the center to any point of the circle. That is the radius. It is like that all the way around. The diameter is from one point of the circle through the center to another point of the circle. It is basically 2 times the radius. And this is a chord from one point of the circle to another point of the circle. Any points. So as you see, it's just random points. Now secant, it goes through the circle, so it's just infinite. This chord stops, the secant keeps going. This is a tangent line. It basically touches the circle once. This point that it touches, though, is called the point of tangency. Coplanar circles that intersect at one point are called tangent circles. Coplanar circles that have common centers are called concentric circles. So this would be a tangent circle. This connects at 2 points, and these circles connect at no points. A common tangent is a line or segment that is tangent to 2 coplanar circles. So this is internal. As you see, it's between the 2 circles. This is outside of the 2 circles, as you see. Tangent line to circle theorem. A line is tangent to a circle if the line is perpendicular to a radius of a circle at the endpoint of a circle. So, if this line is perpendicular to the radius, so we have our center, it connects to any point to the circle, so this part is our radius here, and this line is tangent to the circle because these 2 lines are perpendicular. That's why they also make a 90-degree angle, because they're perpendicular. External tangent congruence theorem. Tangent segments from a common external point are congruent. So you see the tangent segments from a common external point. So this is our external point. They are both the same length. So they're both tangent because they touch the circle at one point, and they're both from one external point. So they are congruent. What is a central angle? A central angle is an angle whose vertex is the center of a circle. So this is the vertex, and you see this is the center of the circle, and it is right there. So this is our angle right here. This is our center, and this is the angle. So this is a central angle. Now another quick thing to point out is, let's say you see a diagram like this, okay? This part is the minor arc. And the rest of it is the major arc. So the smaller arc in a circle is the minor arc. The bigger arc in a circle is the major arc. Congruent central angles theorem. If 2 central angles are congruent in the same or congruent circles, then 2 minor arcs are congruent. So if 2 central angles are congruent in the same or congruent circles, then 2 minor angles are congruent. So this is congruent. So BC is equal to DE if and only if this angle right here is equal to this angle right here. So let's say this angle was 90 degrees, okay? This is not drawn to scale, but let's say this is 90 degrees, okay? Then if this is also 90 degrees, that means BC and DE of the circle are the same. In the same circle, or in congruent circles, two minor arcs are congruent if their corresponding chords are. So this line and this line are congruent if, this line and this line. This is also vice versa. So we could say AB could be congruent to CD if the circle part of AB is congruent to CD. See what I'm saying? Perpendicular chord bisector theorem. If the diameter is perpendicular to the chord, then the diameter, the chord, and the arc. Okay, that's not worded properly, but I'll show you, okay? So, EG, this part is E. E to G is perpendicular to D to F, right? We can see that. Then H to D is equal to H to F. So H is our center. H to D is equal to H to F. And then G to D is equal to G to F. Okay? Also remember that lines are 180 degrees. So that actually helps a lot. Like 90 degrees are equivalent when it's perpendicular and so forth. Equidistant chords theorem. In the same congruent circles, two chords are congruent if they are equidistant from the center. Okay, so this is a chord AB, CD. They're both chords, and they are both, this is our center, they are both the same length from the center. Let's say this one, FE is 2 and EG is 2. That means that these two chords, CD and AD, are equivalent. Now this is our inscribed angle and intercepted arc. So our inscribed angle is this squiggly line on the angle. That's our inscribed angle. And our intercepted arc is this. Basically, it went through. That's how I like to think of it. So angle B intercepts A and C, right? It came between them, like the circle already existed and that came between them, so it intercepted them. AC subtends angle B. So basically subtends means to take up the opposite side of the angle. So AC subtends angle B. And AC subtends angle B. Okay? Now, measure of an inscribed angle theorem. Okay? ADB is half of MAB. Okay? So basically what that means is, let's say an angle is from the center. Okay? It just goes like, if you can see my cursor, it just goes like this. Okay? That means the angle is the same as the length of that arc point, right? But if it goes to an outer edge and then it goes like the diagram we see right here in red, then half of the circle's length is equal to this, is equal to the angle. Likewise, 2 times the angle's length is equal to the circle. Inscribed angles of a circle theorem. So we have ADB is equal to DAC. ADB is equal to ACB. Likewise, DAC is equal to DBC. Okay, so they're just equal to each other because they're both inside the circle. An inscribed polygon. An inscribed polygon is when all the vertices lie on a circle. So as you see, this shape, all the vertices lie on the circle, right? Both of these shapes. The square is perfectly touching all of its vertices on the circle, okay? So ABC is equal to 90 degrees if AC is the diameter. Okay, that's pretty simple enough, just like a rule. If AC is a diameter, the B is 90 degrees, okay? Inscribe quadrilateral circle, okay? A is our center, and D, E, F, G is our square. It's vertices. So D plus F is equal to 180 degrees. E plus G is also equal to 180 degrees, okay? Thank you for watching. Please like and subscribe for more videos like this one by Think Sapling.